We solved fourth question of electric circuits from the Gate EEE 2021 question paper. The question given is the input impedance Zin of S for the network shown is. The network is given as coupled circuit. So in this coupled circuit, at the primary side 4 ohms resistance is given and 6 Henry self-inductance is given. At the secondary side 4 Henry self-inductance is given, 1 Henry mutual inductance, 5 ohms is the resistance at the secondary side. They asked the input impedance in the S domain, that is represented as Zin of S. 4 options are given. So this question is given under the topic mutual inductance. First let me recall mutual inductance concept. So mutual inductance, this constant is represented by the term M. So here, when a coil, consider one coil, it is excited by a voltage source. When it is excited by a voltage source, we know a magnetic flux will be set up around the coil. You know this. When another coil is placed close to this coil, a magnetic flux will be induced in this coil due to the first coil flux, that is a part of flux which is set up in the first coil that will be induced in the second coil. When another coil is excited by some other voltage source, due to this flux, that is a part of flux which is set up in the coil 2, that will be induced in the second coil. So that is known as mutual induction. That principle is known as mutual induction. So the constant of proportionality is given as is termed as M, which is proportional to the phi. That means flux. Okay. So to solve this problem, we have to know the dot representation for the coupled circuit. There are two cases for the dot representation. This dot representation indicates the nature of the polarity. It represents the nature of polarity. That means whether it is of opposite polarity or same polarity for the self-induction and mutual induction. And here, let me consider the two coils which is placed close to each other, and when dot is given here and when current I1 is the current at the primary side and I2 is the current at the secondary side. When I1 is here, I1 is entering at the dotted end in the first coil. Here I2 is leaving from the dotted end in the second coil. So one current enters at the dotted end and one current leaves from the dotted terminal. So I1 enters, I2 leaves. So there will be opposite polarity of each other, opposite polarity for L terms and M terms. L terms means self-inductance terms. That means self-inductance and also self-induced EMF. M terms means mutual inductance and also mutual induced EMF. So it is of opposite polarity. This is for case 1. Case 2. The dotted end is represented here. When both the current at the primary side and at the secondary side, both the current enters or both the current leaves from the dotted end, means I1 and I2 both enters or leaves. Enters at the dotted end or leaves from the dotted end means there will be of same polarity. Same polarity for the L terms and M terms. Self-inductance and self-induced EMF, mutual inductance and mutual induced EMF. So that can be represented here. Here I1 is entering at the dotted terminal. So that means plus minus for the L terms. So opposite polarity is minus plus for the M terms. And here L1. Here I2 is leaving from the dotted end. So minus plus. It will be opposite polarity. So L2 is represented like this. So opposite polarity means plus minus for the mutual inductance. And here at the same time Here in the second case, both the current enters or leaves from the dotted end. So it means when it is plus minus here also the same plus minus for the L terms and M terms. So here plus minus for the L2, plus minus for the M2. M mutual inductance. So this is the basic principle to solve this problem. So let me come to the problem. They asked the input impedance in the S domain network. So let me draw the S domain network first. So at the primary side resistance, inductance, at the secondary side L2, resistance is given. So this one is Z in of S. So S domain network. This is S domain network. We are converting the given network into Laplace domain. So Laplace transform of resistance, Laplace transform of 4 is constant is same 4, and Laplace transform of 6 Henry is, that means self inductance is 6s, and here Laplace transform of 4H is 4s, Laplace transform of resistance is 5, and for mutual inductance 1s. So let me consider I1 of S as the current at the primary side, and I2 of S is the current at the secondary side. So dot representation is given here. So I1 of S is entering at the dotted end at the primary side. I2 of S is the current at the secondary side, which is leaving from the dotted end. So let me consider the first case. So it is of opposite polarity for the self inductance terms and mutual inductance terms. So here plus minus for inductance, self inductance, and minus plus for mutual inductance. Here minus plus for self inductance and plus minus for mutual inductance 1s. So let me solve the problem by using Kirchhoff's voltage law. So let me apply Kirchhoff's voltage law for the primary side. So 4 I1 of S, resistance 4 I1 of S plus 6s into I1 of S minus, because mutual inductance is of opposite polarity, so minus S I2 of S, because flux in the coil 1 is induced due to the secondary current. So minus S into I2 of S, that is equal to V of S. Okay. So simplifying this, I1 of S is taken as common. So I1 of S into 4 plus 6s minus S I2 of S equal to V of S. So take this as first equation for the primary side. And now applying Kirchhoff's voltage law for secondary side. So in the secondary side, I2 of S is the current at the secondary side. So 4s into I2 of S plus 5 I2 of S. Here self inductance and mutual inductance is of opposite polarity, minus S into I1 of S. So at the secondary side, mutually induced EMF will be due to the flux set up in the first coil. So that means current at the first coil. It is due to the current at the first coil. So minus S into I1 of S equal to 0. So this is simplified as I2 of S is taken as common. 4s plus 5. I2 of S into 4s plus 5 minus S into I1 of S equal to 0. So here what we have to find? We have to find Z in of S. So Z in of S is, this is taken as second equation. Z in of S is, input impedance is V of S by I1 of S. So first we have to find I1 of S. So we can eliminate I2 of S from the second equation. So from 2 we are eliminating I2 of S. So I2 of S equal to S into I1 of S by 4S plus 5. Now substituting I2 of S in the first equation. So first equation is I1 of S into 4 plus 6 5 minus S into I2 of S is S into I1 of S by 4S plus 5 equal to V of S. So let me simplify this one. So here I1 of S can be taken as common. So 4 plus 6 5 minus S into S square by 4S plus 5 equal to V of S. So we know we are going to find isn't of S, that is equal to V of S by I1 of S. So transferring this I1 of S to this side, this will become 4 plus 6S into 4S plus 5 minus S square by 4S plus 5. So multiplying this, 16S plus 24S square plus 5 into 4 20 plus 30S minus S square by 4S plus 5. So S square term is 24S square minus S square. So that will become 23S square. S term is 16S, 30S plus 46S plus 20 by 4S plus 5. So this is Z in of S. So options, let me come to the options. So we found Z in of S is 23S square plus 46S plus 20 by 4S plus 5. So option A is correct one. That's all.